All right, today is 5.2. It's labeled Inverse Trig. So what we're going to be doing is learning how to use the sine, cosine, and tangent inverse functions, which are pretty cool because instead of having two sides of the triangle and using that to try to find one of the two sides, this makes it so that if you know all three sides of the triangle, you can use inverse trig to find angles that you don't know. So in this one, when we use the regular sine, cosine, tangent, you use the sides and an angle to find a missing side. The inverse, you're going to use the sides to find a missing angle. So this is what it's going to look like. Remember, an inverse of a function reverses the inputs and the outputs. So the regular sine function, we have an angle that goes in the function and it spits out two of the sides in a ratio. Now sine inverse is going to switch these two with each other, and this is what it looks like below. This sine to the -1 means inverse sine. So you're not raising sine to the -1 power. You are doing the inverse of sine. And what comes after the inverse of sine, instead of an angle like normal sine, you get the ratio of sides. And the angle goes on the opposite side, where the ratio used to go. So these two are just switching places. And again, what's cool about that is if I know two of my triangle sides, I can find an angle without knowing anything else. So a little bit of notation. You're going to be given triangles. Again, right triangles. Again, a symbol or something acknowledging which angle you're using. In this case, it's theta. And we're going to start most of these problems in chapter 5 by labeling the triangle. Across from the 90 is the hypotenuse. Across from your angle is the opposite. And the one that's left over is the adjacent. Poor adjacent, always left by himself. And then you can take those sides and you can put them in the inverse trig functions over here on the left. So let's try this. I've got a right triangle over here on the right. I know all three of the sides, but I don't know the angle on the inside. So I'm going to start by labeling. This side over here is the hypotenuse. This side across from theta is the opposite. This side at the bottom is the adjacent. So if I were to write my trig ratios, I don't have to use all three of them. In fact, I can use whichever one I want, but we're gonna practice writing all three. So sine is what I would normally use if I was looking for a side, but I'm not. I'm looking for an angle. So instead of sine, I'm gonna use sine inverse. And after an inverse, I need the ratio of sides. For sine, sine uses, whoops, that's not the button I wanted. Sine uses opposite and hypotenuse. So I'm going to write opposite on top, 3, hypotenuse on the bottom, 5, and that's going to equal whatever that angle is. Okay, cosine, inverse. Instead of using the opposite and the hypotenuse, this time if I want to use cosine, I need to use the adjacent and the hypotenuse. So on top, I would put 4. On the bottom, I would put 5. And if I put that in my calculator, it would give me that angle that I don't know. Okay, last one, tangent inverse. Tangent uses the opposite on top, the adjacent on the bottom. And in this case, it would give me that unknown angle. So what's nice about these is you can pick whichever one you want, assuming you know all three sides. If I didn't know the adjacent side, if I didn't know adjacent, I wouldn't be able to use whatever I wanted. I would have to use sine because sine uses opposite and hypotenuse. But if I know all three sides, then I can pick whichever ratio I prefer on my calculator. So, examples. This says, using inverse trig functions to find a missing angle, label the sides, decide which function to use, check mode, and calculate. So, we'll go through those one at a time. First of all, label. So, here's my 90. Across from my 90 is the hypotenuse. Here's my angle. Across from my angle is the opposite side. And this 17 that's left is the adjacent. So this problem gives me my hypotenuse and my adjacent. If I wanted to do Pythagorean theorem, I could figure out the opposite side, but I don't need to because I have a trig ratio that uses hypotenuse and adjacent. That's the cosine ratio. But I'm looking for the angle. So instead of using regular cosine, I'm going to use cosine inverse. I'm going to put 17 on top and 37 on the bottom. And when I put that in my calculator, it is going to give me x. It's going to give me that unknown angle. Now, what it means by check the mode, before I type this in my calculator, and we probably should have talked about this on the last video, but if you hit the mode button on the calculator, at the very top are three options. They say degree, D-E-G, radian, R-A-D, and then the last one is G-R-A-D. Radian is something that we use in calculus. You don't want that highlighted. Gradient is something that you use in some of your college and topography classes. We don't want grade. We want degrees selected. If it is not selected, it's going to give you the wrong answer. Now, me telling you this means that there's people that are going to think it's fun to go change it so that you get the wrong answers. So, if you are using one of my calculators, always make sure when you're doing trigonometry to hit the mode button and make sure degrees is highlighted. Otherwise, you're going to get all the answers incorrect, okay? So now that we know that degrees is highlighted, all I have to do is type this into my calculator and it will give me that missing angle. Now that button, that cosine with the -1 is the same as the cosine button. Except on the white calculators, you have to hit the green second button first. On the black calculators, you just hit that button twice, and it will change it to the inverse. So you hit it once for regular cosine, you hit it twice for cosine inverse. You type that in your calculator, and I don't know what that is. 17 divided by 37, I get 62.64, and my calculator's in the right mode. So x is equal to 62.647 degrees. We're going to use 3 decimals on this assignment. And I don't care if you round or if you just cut off the 4th decimal and everything after it. That's called trunking it. So either one works for me. You can either trunk or you can round. I'll give you the right answer. All right, let's try a few more. Example A. I don't know the angle, so that tells me I'm going to use inverse trig to find it. Here's my 90. Across from my 90 is the hypotenuse. I almost wrote opposite. That would have been bad. Hypotenuse. Across from my x angle is the opposite side. See that one? I almost wrote hypotenuse. I'm losing it today. This is the opposite, which means my leftover is adjacent. So I know the adjacent, I know the opposite. Those 2 sides are what go with my tangent function. But I don't want regular tangent. I want tangent inverse because I'm looking for the angle. So opposite goes on top of tangent. Adjacent goes on the bottom of tangent. And when I put that in the calculator, I'm going to get x. I don't like that these are x. I wish that they were theta, but that's okay. So I hit my tangent inverse button. If I can get my calculator in the right place. Tangent inverse of 38 divided by 24. And I get 57.724. and that's not degrees. Well, it is degrees, sorry. This answer is a degree answer. In my calculus class, when we do these problems, we don't use degrees, we use radians. So I'm used to saying it's not degrees. You need to make sure it's radians, but you're not calculus, so don't worry about that. Okay, B, label, across from the 90, hypotenuse, across from the angle, opposite, whatever's left over, adjacent. This one, I don't know the angle. I know the hypotenuse. I know the opposite. Hypotenuse and opposite use sine, but I'm looking for my angle, so I want sine inverse. If I was looking for a side, I would use regular sine, but I'm not. So opposite goes on top. Hypotenuse goes on the bottom. When I multiply that, or when I plug that into my calculator, it's actually not multiplying. When that parenthesis in this case doesn't mean multiply. But when I plug that in my calculator, 5 divided by 11, go away button, then I get 27.035. 27.035 degrees is my X value. Okay, last one, across from the 90 is the hypotenuse. Across from the X is the opposite. Whatever's left over is adjacent. So I'm using an angle I don't know, adjacent and hypotenuse. Adjacent and hypotenuse, that goes with cosine. But I'm looking for the angle, so I'm going to do cosine inverse. Adjacent goes on top. Hypotenuse goes on the bottom. Those are going to equal X when I type it in my calculator. And 9 divided by 15, and I end up with 53.13 degrees. Okay, your turn. Every problem on here, you are going to start by labeling the triangle and then start finding the missing pieces. After you practice this 9 times, there's these cool questions at the end that want you to find all of the missing sides using what you've learned and what you already know about a squared plus b squared equals c squared. So see if you can do those. If you get stuck, come see me. I'll give you a hint. Label first. Always label first. And then from there, depending on what you look for, you're going to do all sorts of different things. There's not one way to solve these. For example, number 10, if I'm looking for H and I make my labels, then F is going to be the opposite. But if I'm looking for G, then 19 is going to be my opposite. So you got to be really careful when you label these, that you label them based on the angle that you're looking for or the angle that you're using. All right? Okay, time's yours. Good luck. Come see me if you need help.